What is the unified field theory? Unification theory refers to a theory that unifies four basic interactions: strong interaction, electromagnetic interaction, weak interaction, and gravitational interaction, one of the representative unsolved problems in physics. In other words, I want to make a hypothesis that all basic interactions in theory can be derived from one basic principle or power. Unified field theory is considered one of the most important problems of modern physics and is expected to lead to a deeper understanding of the basic structure and properties of the universe as well as the development of the theory itself. However, the theory itself has not yet been experimentally verified, and many physicists continue to work on this problem. I want to know about the theory of gravity. Does the greater the gravity, the denser the space? Gravitation theory refers to the theory of gravity acting between objects. As much as gravity interacts between all objects, gravity affects all the objects around us and affects many of the phenomena we see. The greater the gravity, the less dense the space becomes. Gravity is the property of every massed object, and the greater the mass, the greater the gravity. However, gravity does not affect the space or time in which it works. However, in relativity, a theory of the structure of the universe, as the mass increases, the space bends, and the path of light changes or the path of motion of an object can occur depending on the degree of bending. This phenomenon is more pronounced around gravitational objects. Doesn't gravity increase when mass increases? Yes, as the mass increases, so does the gravity. Gravity is determined by the mass and distance between two objects, and as the mass increases, so does gravity. This is also seen in Newton's law of gravity, and the same is true in relativity. According to Newton's law of gravity, gravity between two objects is proportional to the mass and distance of each object, and the larger the mass, the stronger the gravity. For example, gravity between the Earth and the Moon is determined by the mass of the Earth and the Moon, and the distance between the Earth and the Moon. Since the mass of the Earth is about 81 times greater than the mass of the Moon, the gravity between the Earth and the Moon is also felt large on the Earth side. So as the mass increases, so does the gravity. So when gravity is strong, does light refract and space not overlap? Yes, as gravity increases, light refracts, and space bends. This is one of the important concepts in relativity. According to relativity, objects with mass bend the surrounding space, creating gravity. The space is distorted by this gravity, and the movement of light is also affected. A phenomenon in which the movement of light is distorted around a massed object is called a gravitational lens. Also, in the case of objects with very strong gravity, the space itself is bent. This phenomenon is called a black hole, and it is known that the gravity of the black hole is so strong that even light cannot escape. Therefore, the stronger the gravity, the greater the effect on light and space. That would increase the density of space, right? The stronger the gravity, the less the density of the space density. Gravity is the interaction between objects determined by mass and distance, and there is no direct correlation with the density of space. As gravity becomes stronger, the distortion of space increases, causing the orbit of light to bend, or the path of motion of an object to change. However, this distortion or change is not directly related to the density of space, but is a phenomenon related to gravity. Of course, when gravity becomes very strong, the space itself is distorted, resulting in a phenomenon called a black hole. But this, too, is not directly related to the density of space, because the force of gravity distorts space. That is, the distance is contracted by gravity. Yes, gravity shrinks the distance. This has been predicted in relativity, and has been confirmed by a number of experimental evidence. According to relativity, objects with mass bend space. Under the influence of this gravity, the distance appears to contract. For example, because the mass of the Earth bends its orbit, the size of the Moon seen from the Earth looks larger than it actually is. Also, around the black hole, gravity becomes so strong that the space itself contracts. This contraction becomes more severe as it goes inside the black hole event horizon, which allows us to estimate the size of the black hole. Thus, the phenomenon of distance contraction under the influence of gravity has been predicted in relativity, and has been confirmed by a number of experimental evidence.